Let us start organic compounds with halogens as functional group. We will see common names for this. For that, we will see alkyl group common name. We will see alkyl groups common name. We will see. Okay, alkyl group. Alkyl group in the sense we will write CnH2n plus 1. CnH2n plus 1. This is alkyl group. Now we will take N is equal to 4. We will take N is equal to 4 in the sense C4H9. The C4H9 we can write in what way? One possibility is this. It is one possibility. We will give hydrogen atoms here 3, here 2, here 2, here 2. Set. Next possibility we will take the 4 carbon atoms we will write like this, and the hydrogen atoms we will give like this. Hydrogen atoms we are given like this. Next possibility of alkyl group we will write the 4 carbon atoms we will write in this way. Hydrogen atoms we will give like this. Here 3 hydrogen atoms, here 3, here 3 hydrogen atoms. Next possibility we will see the 4 carbon atoms we have written like this. Then we will give hydrogen atoms. We are giving hydrogen atoms like this. Okay, 4 carbon atoms. In all the cases, number of carbon atoms are 4. Therefore, root word in all the cases is but. Root word is but for all the cases. All these cases coming under alkyl group, therefore suffix YL we will give. So YL we are giving. All the cases butyl. Here unsaturation present at terminal carbon and all the carbons present in straight chain, therefore it is called normal butyl, therefore N. Here unsaturation present at secondary carbon, therefore it is called secondary butyl. Here unsaturation present at tertiary carbon, therefore it is called tertiary butyl. It is unsaturation present at terminal carbon, primary carbon, and the second carbon is having 2 methyl groups, therefore it is called iso. Second carbon is having 2 methyl groups and terminal carbon, primary carbon is having unsaturation, therefore iso. So it is isobutyl, it is tertiary butyl, it is secondary butyl, it is N-butyl. Okay. Now we will see another compound CH3, 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 here CH2, like this is there. Unsaturation is there. Unsaturation present at primary carbon, and this carbon is bonded with 4 other carbons, therefore this carbon is quaternary carbon. In this species quaternary carbon is there and the terminal carbon is having unsaturation, therefore we can give neo. Neo is the word. Neo is the word we can give for which case? In the sense, if the quaternary carbon is there and terminal carbon is unsaturated, then we can say neo. 5 carbon atoms present, therefore we can say pentyl. So this is what in the sense neopentyl. This what in the sense neopentyl we can say. Okay, so if we give suppose here Cl, then we will say N-butyl chloride. Here Br means secondary butyl bromide. Here iodine means tertiary butyl iodide. Here Cl means isobutyl chloride. Here Br means neopentyl bromide. Like this common names we can say. So next common name we will see. We'll take CH2 double bond CHCl. Now see that CH2 double bond CH single bond. CH2 double bond CH single bond is called vinyl. CH2 double bond CH single bond is called vinyl. Cl name is chloride. Cl name is what means chloride. Next we will take CH2 double bond CH single bond CH2 Cl will take. This name will take. What is the name of this? We'll see. Here what is the name? Means CH2 double bond CH single bond CH2 single bond. This name is what means allyl. CH2 double bond CH single bond CH2 is called allyl. This Cl name is called chloride. Therefore it is called allyl chloride we can say. Next common name we'll see. CH3 single bond CH double bond CH CH2 Cl. Like this we will take. This is what in the sense crotyl. This is what in the sense crotyl chloride. This name is what in the sense crotyl chloride we can say. Crotyl chloride. Next compound we'll see here, phenyl ring, CH double bond CH, single bond CH2 Cl. This is called what means cinnamyl chloride. This is called cinnamyl chloride. From cinnamic acid we are seeing. It is called cinnamyl chloride. Next compound CH triple bond C CH2 Cl. What is the name of this? This is called propargyl. It is called propargyl chloride. It is called propargyl chloride, we can say. Propargyl chloride. Next compound, you see that phenyl ring, here CH2Cl. Next phenyl ring, here CHCl2. CHCl2. Next phenyl ring with C is having 3Cl. 3Cl, like this is there. Now what is the name, we'll see. Here side chain is having 1 chlorine, side chain carbon is having 2 chlorines, side chain carbon is having 3 chlorines. Okay. Now here this is called what in the sense? That is C6H5CH2 is called benzyl. C6H5CH2 is called benzyl. C6H5CH is called benzol. Is called benzol. C6H5C C6H5C is called benzo. Is called benzo. Okay. So now Cl name is you can say chloride. Here Cl name is chloride. Here Cl name is trichloride. 3Cl. Therefore here we are saying trichloride. So here 2 chlorine, therefore dichloride. Okay. So it is a benzyl chloride. It is benzol dichloride. It is benzo trichloride. Benzo trichloride we are saying. So like this common names we said. Some more common names we'll see. Now we will take a C2Cl6. Respective hydrocarbon we'll see. Respective hydrocarbon is C2H6. C2H6 in the sense ethane. C2H6 in the sense ethane. If all the hydrogen atoms are replaced by halogens, then we have to say just perchloro. Cl is there, therefore perchloro. Perchloro, if you say chloro in the sense Cl. Perchloro, if you say all the hydrogen atoms are replaced by Cl. All the hydrogen atoms of ethane is replaced by Cl, therefore it is called perchloroethane. We'll see one more example for this. Now CF3, CF2, CF3. CF3. It is if instead of hydrogen, instead of fluorine atoms, hydrogen atoms are there, means then it is propane. Propane. Instead of hydrogen is what is there? Fluorine. Therefore fluoro. All the hydrogen atoms of propane is replaced by fluorine. Therefore we have to say perfluoropropane. Then we will take C6F6. Instead of F, you take H. Then it is called benzene. F is there, therefore fluoro. All the hydrogen atoms of benzene is replaced by fluorine, therefore it is called perfluorobenzene. So C6F6 we can say what in the sense perfluorobenzene we can say. Sir. So these somewhat common names we have seen. Next we will go for a preparation of halides. We'll see. Now we will go for preparation of halides. Preparation of halides. In the halides, in the sense, which halides we are taking? One possibility alkyl halide, one possibility aryl halide, one possibility alkyl halide. Alkyl halide. So, alkyl halide C2Cl6, one example you can say. Aryl halide C6F6 also one example. Alkyl halide means what is example? These are her alkyl halides. That means her means aromatic phenyl ring is there, alk means CH2 is there. Therefore, these are her alkyl halides. So benzyl chloride, benzol dichloride, benzo trichloride are called her alkyl halides, we can say. This is alkyl halide, we can say. Okay, sorry. In this alkyl halide, functional group triple bond is there. Sorry. So how to prepare halides, we'll see. Now first conversion of alcohol into halide, that we'll see. Conversion of alcohol into halide. So now we will take alcohol, we are taking this alcohol, we are converting into halide. So to convert alcohol into halide, what we can use? What we can use in the sense, we can use halogen acid, HCl, HBr, HI, like this is there. No, that halogen acid we can use, or phosphorus trihalide we can use, PCl3, PBr3, like this. Phosphorus pentahalide we can use, PCl5, phosphorus pentachloride, or SOCl2 we can use, thionyl chloride. So if you use like this, what happens means alcoholic OH group is converted into halogen. Alcoholic OH group is converted into halogen. Okay, let us see one example. First, with halogen acid we'll see. Now we are going for alcohol with halogen acid. With halogen acid, how the reaction will be there, that we'll see. Now, so alcohol with halogen acid, what is the mechanism, that we'll see. Alcohol with halogen acid. Okay, now I am taking alcohol. In the alcohol, oxygen is having 2 lone pairs. In the halogen acid, I will take H plus. So it is donating lone pair to this. Therefore, what happens means we are getting a oxonium ion. Oxonium ion we are getting. Oxonium ion in the sense oxygen is having positive charge. Then X minus comes. This X minus is having 4 lone pairs. X minus is having 4 lone pairs. It is attacking this R. This water is leaving. Therefore, we are getting RX. Okay. So here this oxygen is attacking H plus. So we are getting oxonium ion. Then X minus is attacking. This water is leaving. So we are getting a halide. We are getting. Sir. Now, in the place of alcohol, let us take primary alcohol. Let us take primary alcohol. In the halogen acid, we will take HCl. HCl physical state is gas. Then we will take anhydrous ZnCl2. Anhydrous ZnCl2 will take. We are taking anhydrous ZnCl2. What is the compound we are getting? Means CH3, CH2, Cl. This is the compound we are getting. Then water we are getting. Sir. Now, what is the chemical reaction that we will see here? This mechanism will see. This alcoholic part will take this CH3, CH2, OH, in which 2 lone pairs are there. HCl will take, Cl is having 3 lone pairs in HCl. This lone pair attacking this H, this bond pair is migrating. So we'll get CH3, CH2, OH2 plus. O is having 1 lone pair, plus charge is there. Cl minus is leaving. Cl minus is having 4 lone pairs. Cl minus is leaving. Next, what happens means Zn2 plus comes from anhydrous zinc chloride. From anhydrous zinc chloride, Zn2 plus comes. This lone pair is making dative bond with Zn2 plus. So we will get so and so. Therefore, now here positive charge magnitude. Here, how the positive charge magnitude will be there means will be high when compared to this oxygen. In this oxygen, positive charge magnitude will be high when compared to this oxygen because it acted as donor for this Zn2 plus. Because of higher positive charge at this oxygen, what happens means this bond is shifting towards this oxygen, Sir, how that shift will be there, that we'll see. How that shift will be there, that point we'll see. Now here, what is there means CH2 group is there and CH3 group is there. Now, which group comes for attack means the Cl minus. It is coming for attack. This lone pair is attacking this backside of this carbon. This bond is shifting to water, oxygen. Therefore, this is becoming what we'll see. This becoming a, that is becoming what in the sense C, H, CH3. Here Cl. So here what is produced in the sense HOH plus charge, Zn2 plus. Zn2 plus is having plus charge. Otherwise, we will do one thing here 2 plus. If you write, don't give plus charge here, you give this is as a dative bond. So next point, what happens means this Zn2 plus leaves. Therefore, here we are getting water molecule and Zn2 plus. That means this anhydrous zinc chloride is helpful for removing water from alcohol. Therefore, anhydrous zinc chloride is acting as dehydrating agent. Anhydrous zinc chloride is acting as a dehydrating agent, removes water, sir. So because of this Zn2 plus, what happens means between this carbon and oxygen bond becomes weak. That means this bonding electron cloud goes towards oxygen. Therefore, less electron cloud present in the bond. Therefore, bond becomes weak. So easily this bond breaks. So this Zn2 plus is making this bond to break easily. Sir, okay. So now here what is a reaction we'll see. In this what happens means this instead of OH group the Cl comes here. Okay. So now this reaction we can call it as what in the sense substitution reaction we can call. Sorry. So this primary alcohol with HCl gas in the presence of anhydrous zinc chloride gives a primary chloride. Okay, ethyl alcohol gives ethyl chloride. So next we will take isopropyl alcohol. Next we are taking isopropyl alcohol. It is second carbon. The second carbon is having two methyl groups. Therefore, it is isopropyl alcohol. It is treated with a HCl gas. Then we are taking anhydrous zinc chloride. We are taking. This OH group is replaced by Cl. OH group is replaced by Cl. It is called isopropyl chloride. It is secondary. Next we'll go for tertiary. We'll take a tertiary alcohol. We'll take to this HCl gas. We will pass. Now here reaction takes place even in the absence of ZnCl2. Even in the absence of ZnCl2, reaction is possible, and we are getting a tertiary chloride. We are getting tertiary chloride here. Tertiary chloride we got. Okay. So tertiary alcohol in the sense ZnCl2 is not required. Whereas primary alcohol and secondary alcohol means anhydrous ZnCl2 is required. Tertiary alcohol means anhydrous ZnCl2 is not required. What is the reason? What is the reason in the sense? Now we'll see. Now primary alcohol is going for protonation. Therefore, we are getting oxonium ion. Secondary alcohol is going for protonation. Therefore, we are getting oxonium ion. Tertiary alcohol is going for protonation. Therefore, we are getting oxonium ion. We are getting oxonium ion. Now, this methyl group shows plus A effect. This methyl group shows plus A effect. This methyl group shows plus A effect. This tertiary butyl group shows plus A effect. Here methyl group shows plus A effect. This methyl group shows plus A effect. This carbon shows plus A effect. Isopropyl group shows plus A effect. Here methyl group shows plus A effect. Methylene group shows plus A effect. Ethyl group shows plus A effect. So where plus A effect is much high means in this place plus A effect is much high. Here somewhat less. Here still less. Therefore, where water can detach easily? In tertiary alcohol. Therefore, tertiary alcohol goes for reaction even in the absence of ZnCl2, we can say. Next. So far we have prepared a chloride. Next, how to prepare bromide, we'll see. How to prepare bromide. Now we'll take alcohol. This alcohol is treated with a con HBr. This alcohol is treated with con HBr. What is the percentage of concentrated HBr in the sense 48%? We can take con HBr, we can take, otherwise what we can do means we can mix salt and concentrated sulfuric acid we can mix. We can mix salt, KBr and concentrated sulfuric acid. From these two we will get HBr. That HBr is attacking this alcohol. So that what we are getting in the sense the bromide will get. We are getting a what compound in the sense bromide compound we are getting. We got a bromide compound set. Now we will take what in the sense primary alcohol we will take. If you take primary alcohol, that is ethyl alcohol, if you take, we will get a product ethyl bromide. We will get a product ethyl bromide. Sorry. If you take a secondary alcohol and a tertiary alcohol, if you take secondary alcohol and tertiary alcohol, we are not getting bromide. We are not getting bromide. If you take secondary alcohol and tertiary alcohol, we are not getting bromide. But primary alcohol gives bromide. Secondary and tertiary alcohol with concentrated HBr is not giving bromide. What is the reason? That we will see. Now we will take a HCl, HBr, HI will take. HCl is a strong acid, therefore it gives H plus ions and Cl minus ions. HBr is strong acid, so that it will give H plus and Br minus. HI gives strong acid, HI is strong acid, so it gives HI plus and I minus. Down the group, if you go, what happens to the bond strength? Bond strength decreases. Therefore, acidic nature increases. What experimental evidence says? That we'll see. Before that, based on bond strength, we said this bond strength is low when compared to this, so this bond is easily breaking when compared to this. So down the group bond strength is decreasing, therefore extent of dissociation rises, therefore acidic nature rises. That means HI dissociates to more extent when compared to HBr. HBr dissociates to more extent when compared to HCl. That is the thing. Therefore, here concentration of H plus is more when compared to this. Here concentration of H plus is more when compared to this. So, now based on electronegativity, we will say, okay, based on electronegativity. If we go like this, what happens to the electronegativity of electronegativity? What happens means electronegativity decreases. That means which is having higher electronegativity means Cl is having higher electronegativity when compared to bromine. Bromine has higher electronegativity when compared to high. Electronegativity decreases means acidic nature decreases, because Cl is having high electronegativity than bromine. So Cl pulls this bond pair to more extent than bromine. Therefore, Cl is pulling bond pair to higher extent when compared to bromine means this from here H plus easily comes when compared to this. This is based on electronegativity. So based on electronegativity, HCl is having more acidic nature than HBr. So now we will see experimental fact. Experimental fact in the sense using acid dissociation constant, Ka value. Using Ka value, we can say acidic nature. Ka value, how it is there in the sense, Ka value increases down the group. Ka value increases down the group means acidic nature increases down the group. It is experimental fact. So, which theoretical concept is suitable for explaining this experimental fact in the sense this bond strength, but not electronegativity. So, to explain this experimental fact, use bond strength. Don't use electronegativity. Therefore, HI acidic strength is more when compared to HBr. HBr acidic strength is more when compared to HCl. Okay. Now you know that Lowry-Bronsted theory says that higher the acidic nature of acid, lesser the basic nature of its conjugate base. Therefore, if you go down the group, if you HCl, HBr, HI, if you take like this, acidic strength increases. Therefore, if you go like this, how the basic strength happens means basic strength decreases. So Cl minus is more basic than Br minus. Br minus is more basic than I minus. Okay. So Br minus basic strength is what means less when compared to Cl minus. I minus basic strength is still less when compared to Br minus. But HI acidic nature is more when compared to HBr. I minus basic strength is less when compared to Br minus. So how the acidic strength is there? How the basic strength is there, that we got an idea. Now we have to discuss primary alcohol gives bromide, whereas secondary alcohol and tertiary alcohol is not giving bromide. Why is it so? Then regarding chloride, primary alcohol, secondary alcohol, tertiary alcohol, I have given chloride. Secondary alcohol is giving chloride, but secondary alcohol is not giving bromide.